Yes, sir.
So a good question to ask might be something like, will we get a circle on the test? I mean, actually
Right.
it does actually look like it now that I'm looking at 30. 30 is a circle as well.
Right. Okay.
All right. So any questions on 20 before we move on?
No.
Okay. Are you comfortable completing the square?
Yes.
Okay. All right. Number 30, the endpoints of a diameter. So that's enough to tell you that it is a circle, because only circles have diameters. You could graph these points just to get an idea of where it is. So like -2, 4 would be there, and then 6, 2 is there. And you can kind of get an idea. Well, that's not drawn very well. So the diameter though is somewhat helpful. You need the following for a circle. Well, you need the equation, but you need h, k, and r. And you can get them from the two endpoints here. So the h and k come from the midpoint. Okay, so the midpoint is the average of the x's and the average of the y's.
Right.
Okay, so think of it as -2 plus 6, that's 4 divided by 2, that's 2. And then the y's, 4 plus 2 is 6 divided by 2 is 3.
Right.
Okay, and so that's h and k. The radius is half the diameter. You learned that in geometry, maybe before then, but you don't have the length of the diameter. So use the distance formula.
Right.
Use the distance formula here. So the distance formula, I'll just write it out here, is y2 minus y1 squared plus x2 minus x1 squared, square rooted. So the if you need to, you can label these, x1, y1, x2, y2. Doesn't really matter how you do it, as long as you get the right numbers in the equation. It's 2 minus 4 squared plus 6 minus a minus 2 squared. Okay, and you get -2 squared, 8 squared. So you end up getting 4 plus 64, which is whatever it is, the square root of 68. Okay. Now you might think to like reduce that root. You can, but you don't have to. Okay. Because when it goes back into here, you're going to square it. So the square root's going to go away. All right. So right now, this is the diameter. All right. So we want to take half the diameter. The radius is half of the square root of 68. But if we want r squared, we're going to square it. Take half of it and then square it. So half, 1/2 squared is 1/4 times 68. And then this becomes 17.
Okay. Wow.
Okay. So, we needed that because we really don't need r, we need r squared. So we can write r squared as 17. So we now have everything we need for this equation here. All right, so we're gonna rewrite the equation with the values of 2 and 3. So we got x minus 2 squared plus y minus 3 squared equals 17.
Okay.
Now, if you look at the answer, it says like write it out in this form where you foil combine like terms.
Right.
So we have to do that. We have to foil both of these. So we got x squared minus 4x plus 4. Y squared minus 6x plus 9. And then they want you to regroup everything. And I'm not sure why, but that is the format. So they want it in this form: ax squared plus by squared plus cx plus dy minus e equals 0. So you have to put the x squared first, and you kind of mark things off as you go. Then the y squared, then the minus 4x minus the 6x. And then you actually combine the 4 and the 9, so that's 13. And then you subtract the 17 from both sides. So you subtract the 17 over, and that's where sorry, this is a y, 6y. Got that in the wrong spot. Like that.
Why? Oh, okay. Never mind. Wait, yeah, no. Why do you subtract the 17?
It wants, so remember, we're starting from this line and just rearranging. It just wants 0 on the right hand side.
Hmm. Okay. Okay.
All right, so next page here, you say 7 through 14. This is kind of the heart of your exam here, is exactly what it's asking for. You have to identify what it is and then all the features of it. Excuse me. So let me know when you get all this down, and then we'll move on to number 7.
Got it.
Okay. All right. So my recommendation here is to group, and they kind of already are. Well, so we're gonna subtract 10 from both sides. That's the first thing. X squared minus 8x. Okay. We're gonna leave a little space. Minus 2y squared plus 4y equals minus 10. Okay, so we gotta complete the square with x, and then we've got to complete the square with y here. So do you remember, can you tell me what number goes in this red position?
Is it 8?
It's the last number squared, minus 4 squared.
So positive 16?
Positive 16, good. Okay, great. Now, this is where it gets more complicated. There's many different ways to do the completing the square with the coefficient in front. I like to factor it out.
Right.
I factored out the -2 from both of these, and then also from this one. So it means an extra line of work, but I feel like it's more doable this way because it's like the ones we've been doing. So the -2 does come down. First of all, it's y minus 1 because that's half of this 2 here. Now the number that goes here is -1 squared. -1 squared is +1. Let me actually do it in blue. It's +1. Now, if you recall, to go from these 3 terms here to these 3 terms here, I factored out a -2. To go backwards, it's like multiplying in by -2. So notice it would be negative 2y squared. We have that. Negative times negative 2 is positive 4y. We have that. Negative times positive 1 is negative 2. You're used to having positive numbers when you complete the square, but it is not always the case.
Hmm.
So I mean, that's what makes this so tough. It's just all these little pieces here. So on the right hand side, you got negative 10 plus 16 minus 2. So that ends up equaling 4. Thank goodness for that. Okay. Now this is the point where it's like, all right, well, what is it? There's a subtraction operator. So that's a pretty good indicator that it's a hyperbola.
Right.
And hyperbolas always have 1 on the right, so you're going to divide both of these by 4. You have x minus 4 squared over 2 squared minus y minus 1 squared over, now it's really 2 on the bottom, but I'm going to write it this way, square root of 2 squared equals 1. So 2 divided by 4 is really 1/2, but you want to show the a and the b so that they're such that they're squared.
So they have to be squared like that. They can't be like 4 and 4.
It would be 4 and 2 actually. Let me show that. It'd be 4 and 2. And then when I show you the form here, let me get this up as a reminder. So this is the horizontal transverse axis. You can see the form. See how it's a squared on the bottom, b squared on the bottom.
Yeah.
So that's why you almost want to rewrite the 4 as 2 squared, and the 2 as the square root of 2 squared, like that. Excuse me. I know it's a little awkward. Like it's nice when they are nice numbers here. You know, when it's not a nice number, friendly number, you're just frustrated, maybe. Okay. So we've done, it might feel like we've just done a bunch of stuff, but that is just identify the conic section. That's just part A. If it is a hyperbola, find its vertices, the asymptotes, its conjugate axis, its foci, and its asymptotes. Basically everything we've been finding. So you have to find H. Do it over here. H, K, A, B, and C. And so H and K come from the parentheses. What's H and K here?
H is 4.
4, good.
K is 1.
Good.
A is 2.
2. B is the square root of 2.
B is the square root of 2.
Yeah.
C is, how do we find C again?
So C squared equals A squared plus B squared. But it's different for an ellipse. Just keep that in mind. It's different for an ellipse. So here you got it's 4 plus 2. So it ends up being the square root of 6.
Why the square root of 6? Can you explain that?
Sure. Sorry, I'm skipping steps here. I shouldn't do that. So it's 2 squared plus the square root of 2 squared. Just using the A and the B values in here. So 2 squared is 4. Square root of 2 squared is 2. This is 6. Take a square root of both sides.
Okay.
C equals the square root of 6. Okay. So all of that stuff's really important to find because everything you're asked for comes from those numbers. That's why they're so important. So this is the the center, the vertices, foci, and then the asymptotic equations. Okay, so your center is HK. We've got that down. That's 4, 1. H plus or minus A. So it's 4 plus or minus 2. So we actually have to do it this time. There's 2 of them. 4 plus 2 is 6. 4 minus 2 is 2. And then the K is the 1 and the 1. And the H plus minus C, that's 4 plus minus square root of 6, comma 1, comma, that's it. That's it for that one. All right. And then the asymptotic equation, y equals k, which is 1 plus or minus b over a, square root of 2 over 2, x minus 4. But then it wants a graph. Of all things, it wants a graph. So the graph here, let me know when you get caught up. Sorry.
No, I'm caught up.
Okay. The graph, you start at that center.
Mhm.
So you start at 4, 1 right there. And then I recommend using the asymptotic equation. So you're already at 4, 1. So you don't have to go anywhere. This square root of 2 over 2 is your slope. So you have to kind of remember, well, what is square root of 2? It's like 1.4. So you're going up a little bit more than 1 and right 2, up a little bit more than 1 and right 2. And you just want to get kind of a rough idea of that. Then you go the other direction. So minus square root of 2 over 2, minus square root of 2 again, minus 1.4-ish, and then right 2, something like this. So this will frame it. And then you get the vertices. You go for the vertices. So 6, 1 and 2, 1. And this gives you the shape of this thing.
So the asymptote line is the line that shows where the curve is going to bend.
After you have the vertices, because if the vertices were up and above, you would be graphing them up here and down here.
Okay.
Can't emphasize enough that all this comes from knowing the equations and once getting H, K, A, B, and C, knowing the equations, writing the stuff out, and then just piecing it together. You've got to do it from the center and then the equations, then the vertices, because the foci are going to be in here somewhere. They're always inside they're inside there, but it's the vertices that tell you where it's going to connect.
Okay. So even though the center is like here, it's never at the same place as the vertices, because the vertices is somewhere.
That's right. The center is actually the middle point between the 2 vertices.
Huh. Okay. That's weird, but okay.
Any other things?
No, that makes sense.
All right, let's do another one here. And these don't like get easier. 8 is different than 7, so. Okay. All right, so the again, kind of got a completing the square situation. You got to move the constant over, and then you group the x terms together, leave a space. 2y squared plus 8y, leave a space. Minus 71. So you put a little like link or bucket here. We're gonna work them individually. In both the x and the y here, we're gonna have to factor out a number first, and that's
we could factor out 9x.
just the 9. And I know you think, okay, there's got both x in it, but it's just the number, because you wanna complete the square.
Right. So that would mean the first blank is 36.
So it's x minus 3 squared. What goes in here? It comes from this number down here. What goes in here?
36.
Yeah, 3 squared. 3 squared.
Oh, 36. So it would be 9.
It'd be 9. And then this is where it's a little bit awkward, because you're multiplying in this 9x squared. 9 times 6x is 54x. 9 times 9. So this is plus 81. Plus 81. So I really want you to focus on like kind of this, how we went down and then we went back up. Like try to, we wrote the 3 is half of 6, squared the 3 to get 9, and then we multiplied by 9 to get the 81.
Right. So it's better to work from bottom to top than it is to work from top to bottom.
Yeah, you don't start up here. You go down, then come back up. At least the way I show it. I mean, all of these lines are equivalent. The 3 terms, and this right here.
Okay.
All right, so now we're gonna do the same thing. We're gonna factor out a 2. So it's y squared plus 4y, leave a space. What goes in the bottommost parentheses? Because you do work it down first. What goes in here?
Y plus 2 squared.
Good. It's half of this number 4. So the number that goes back here
is also 4.
Is also 4, but then you got to multiply by 2.
By 2?
Yeah, the 2 on the outside. See how there's this 2 here on the left? If
Yeah.
you multiply each of these by 2, you get back to the previous line. So
Right.
this becomes plus 8. Plus 8.
Oh, that makes okay. I was gonna ask why didn't we do that with the other one, but that's because it was 9. So 9 squared is
No. It's because 9 times 9 is 81. You are multiplying in each time.
Right.
And we did that in the previous one too. I'll just show you that over here. See, we minus 2 times y squared minus 2y squared minus 2 times minus 2y is 4y. Minus 2 times 1 is minus. Times that. Equals 18. Okay. So now you notice there's a plus in the middle. That tells you that it's an ellipse or circle, but it's an ellipse because there's a 9 and 2 are different. They're not the same. If they were the same, it would be a circle.
Right.
So you divide everything by 18. X minus 3 squared over 2 plus y plus 2 squared over 9 equals 1.
I was gonna ask why 18, but I see now. I'm a little behind.
Okay, so yeah, let me get back up here. Please ask questions.
Okay. Minus 3 squared over. Why is it over 2? Oh, because you're dividing by the. Okay, that makes sense. Line It's 2 squared. Okay, got it.
Okay. So that we have not talked about ellipses, and I'll just snip in the part of the reference sheet. I can send you a link if you still need it. But this one's a little bit harder because it's like, well, what's going on here? Like these look really similar. And here's what you have to remember. A is greater than B. A is greater than B. Okay, so what that means is the bigger number is A. So this is A squared. And it has to do with the fact that the A squared equals B squared plus B plus C squared.
Okay. Okay.
Right.
So
So that's important. Like you have to let like this is A squared and this is B squared. And that tells you which one it is because notice how X could be over B or X could be over A, and it depends on which one it is. So this one is the vertical major axis.
oh. Wait, I'm sorry. Can you go over why B is with X and not with Y? Because isn't it normally with Y?
But notice, see how X could be with B or X could be with A, Y could be with A, and Y could be with B. And the question's a reasonable question. Well, how do I know? The answer is A is always bigger than B. So the one that's bigger on the bottom is A.
Okay.
That's the best way to do it. And then that tells you which one it is, which in this case, because the A goes with Y, it's the vertical major axis.
Okay. Okay. All right. That makes sense.
Okay, so just like before, we've got to do H, K, A, B, and C. It's like it's the same thing over and over again. So give me H and K here.
Uh, uh, H is 3, K is -2,
Good.
A is 3, and B is square root of 2.
Good. Now what's different is that you've got a different relationship between A squared, B squared, C squared. It's not the same for an ellipse as it is for hyperbola.
Mhm.
Okay, so to do this, you have to say A squared equals B squared plus C squared. Not A is 3, B is the square root of 2 squared plus C squared. So 9 equals 2 plus C squared. 7 equals C squared. So C is the square root of 7.
Okay.
All right, so again, just like the last problems, when you get this table of values, it opens up everything. Like that's why it's so critical to do. Okay, so let me just sequence this a little bit. Grab these numbers here. Okay, so the center here is this one. The center is at 3 comma -2. The vertices H comma K plus or minus A. So H is 3 comma -2 plus 3, 3 comma -2 minus 3. I'm just using the formulas here. So that becomes 3 and 1, 3 and -5. Maybe we rewrite it like that. 3, 1, 3, 5.
Three
All
negative
right.
one.
Yes. Yeah, no, it's positive because it's k plus a. -2 plus
Oh,
3.
oh, okay, never mind.
Yeah. I do make mistakes and I am exhausted right now. So,
Aren't we all?
yeah. Yeah, you come back from vacation and need another day off. Foci 3, comma, -2 plus or minus square root of 7, like that. And then we add in a couple of other things here. So length of major axis. So major is 2 times 3, which is 6. Minor is 2 times b, which is square root of 2, so 2 root 2. So in terms of how do you graph these, you go to the center. Center is not particularly useful this time, but you do need a starting point. So let me know when you get caught up.
Oh. Oh. Okay, I'm good.
All right, so 3, -2 is, it's not a good place for that. Let's go right there. 3, -2 is right there. Okay. So now the vertices come next. So 3, 1 and 3 -5. So 3, 1, 3 -5. Okay. And then really the like what that is, let me color code this here. So the major axis is this right here.
Right.
Okay. Now the minor goes the other way, and because it's not a whole number, it's not all that helpful. And the so if we do this in red here, it's going like left 2 root 2 and right 2 root 2. Or I'm sorry, the whole width is 2 root 2. So it's like root 2 left, root 2 right. So what some students do is they kind of draw these other ones. And these are the places that the graph touches. So it's kind of this football shape. Okay. So you actually don't need some of this other stuff. Now the foci are inside there. They're we're gonna put like they're like here and here. These are the foci.
Right. Why is the center at 2 negative no 2 -3? Shouldn't it be 3 -2?
3 -2. 3 and then down -2. That's the center right there.
Oh, okay. Sorry, I got confused.
Don't worry about it. It's there's so much going on here.
Yeah.
All right. So any questions on that? I mean, that's the, you know, it's the drudgery of conic sections.
No, I just hate cones.
Yeah, these are not pleasant. All right, number 9. So one of the things you might notice pretty quickly about number 9 is that only one of them is squared. So when you see that only one is squared, that means that it's a parabola.
Okay.
And we don't know whether it's the up or the sideways one, but we will shortly. I mean, you do know because of this y, but You at least know that it's a parabola.
Huh. Oh, okay.
Y squared minus 2y. So this one's different. You move you move the both the x's, the x and the y to the other side.
Why?
So this because the form of this. So you complete the square in y, but the x's have to be on the other side in the parabola. So if you look at that conic sections, do you need me to send you that reference sheet again in the
No.
chat? Okay. You'll notice that it's either x squared on one side or y squared on one side.
Okay.
All right, so let's complete the square on the left. What goes in parentheses here?
On the left would be
Right down here,
1
-1.
minus 1.
And then what goes on the right here? I'm sorry, what goes in this bucket, this blue bucket?
Oh, positive 1.
+1, +1. On the right-hand side now, it becomes -4x minus 8. Now, there's a bit
Right.
more to do. You have to factor out the number in front of x. So this
Okay.
becomes x plus 2 like this. And if you stare at the forms of the parabolas, you will find that the x always has a 1 in front, which is why you have to do this. You want a 1 in front of this. Okay, so we're in this form right here. You have to identify a little less here, h, k, and p.
So H would be 1 in this sense.
H always goes with x.
Oh, I can't. Right.
We're practicing for the real thing.
H is -2. K is +1.
Okay, now p is the hard one. You set p, if you set 4p equal to the number in front of x, and that you factored out.
So P would just be -1
Yes, good.
for this one. Okay.
Yes. Now I don't remember this. If p greater than 1, then right. P less than 0, left. It comes out of this other stuff, but you may want to remember that. Not it's up to you. So the vertex here is -2, 1. Okay. The directrix is y equals 1. And then the foci, h plus p comma k. So we got -3, 1 like that.
Hmm.
I'm sorry, this is not the directrix. This is the axis symmetry up here. I'm sorry, that's not right. Sorry, the directrix is down here. So get rid of that. So the directrix is x equals h minus p -2 minus a -1, which ends up being -1.
I see.
All right, so this is enough to graph it here. You start with the vertex -2 -1. So there's that. The foci is -3, 1. Okay, and the foci is always contained inside the vertex, and this is true in all of them. So this tells us that it looks like this. It's confirmed by the directrix, which is this line that is equidistant. Like this distance right here is the same as the distance to the directrix.
Oh. So the foci is the same distance from the vertex.
as the directrix is. Yeah.
Huh.
I know it's like maybe it feels like you're just now seeing this, but this is really a critical stuff. It helps you to not have to memorize the formulas because you can see those things. Maybe you learn one but not the other.
Right. Wait, say again, you can change one but not the other? What?
Well, like if you recognize that, like you just said, the foci is inside the vertex, you don't have to know this equation. You just know that it's equidistant.
Okay.
And like if that doesn't help, I get it. I mean, this is not it's not easy stuff in any way. All right. We don't have enough time to do a full problem here probably, but anyone stand out from you? 10, 10's another quadratic, but it's an X. So you might do that on your own.
Uh, I think 14 was a big one.
Oh, you got to do you got to do 14.
Yeah, he said we had to do certain numbers of them.
Okay. 14, we can sort of work backwards to do these. I mean, this isn't as bad. You want to attempt to draw this a little bit. So the vertices 0 plus or minus 4. So there's 4 and there's negative 4. And so the foci are at plus or minus square root of 15. That's a little bit less than 4. So they're here and here. So that's some good information. That this tells us that because I don't want to say this, because the foci are in line with the vertices vertically,
Right.
that tells you which one it is. Okay, and it's the vertical major axis.
Right.
Okay, so if we come over here, we can use these equations for figuring stuff out. So the vertices is the second one. So it's k plus a equals 4, k minus a equals minus 4.
For foci.
These are vertices.
Vertices. Oh, foci is K plus C.
Yeah, we're gonna do that one next.
Okay, just checking.
So this is 2k equals 0, so k equals 0, and a equals 4. So you still have to find h, k, a, b, and c. So we found that k is 0. H is 0 for this is h right here. And we found that a is 4. To find we use the k plus or minus c. K plus c equals square root of 15. K minus c equals minus square root of 15. So we find that, I don't want to do this. We find that 2k equals 0. So k again equals 0, but we know that c is the square root of 15.
Okay. Where did you get the 2K from? The 2K equals 0?
You add the two equations together, and then you add
Oh,
the
okay.
two equations together. Yeah. All right, from here, you use the relationship that a squared equals b squared plus c squared, and you use this to find c, or b in this case. So we have 4 squared equals the square root of 15 squared plus c squared. So you end up finding that c equals 1. And that's enough to
Huh.
to do this. So you would write out the equation, it's x minus 0 squared over
Right.
1 squared plus, oops, I've got this. Oh, not, wow.
What?
Oh, okay, no, this is fine. This is fine. I'm just trying to, we're just running out of time here. Y minus 0 squared over 4 squared. That's gonna be reversed though. Oh, equals 1. I see. So this, they're doing it weird, but it's x squared plus y squared over 16 equals 1. You multiply by 16, and that's how you get the 16x squared plus y squared equals 16.
Okay.
All right, so I know this is really hard, and I mean, I don't even remember if I even did well on this as a math student.